This video shows how to use Ansys Workbench version 18.1 to model stress concentrations in a flat rectangular plate with a circular hole and notches under a combination of axial loading and bending moment. This is a schematic of the flat plate. It's 1,000 millimeters, a meter long, 140 millimeters deep or high, and 40 millimeters thick. There's a circular hole here. The radius is 52 millimeters. There are two circular notches here. Their radius is 11.5, but they are not. The radius of the notch of the circle is 11.5, but they are 5.5 millimeters into the bar, leaving a clear distance of 128 millimeters between the notches. The loading is 563 kilonewtons axial loading plus a bending moment of 15 kilonewton meters. We'll see from the theory that there are various points of interest marked A, B, C and D where there are stress concentrations, and we'll use Ansys to compare the theoretical results with the finite element results. Before we start using Ansys, there's a couple of settings. It's useful to check. So if we go into Tools and Options, and on the first screen, under the Project Management tab, there are folders for permanent files, for work files. The work is going to be saved, and for temporary files. Now, if you're using this using the DIT vApp virtual network, you need to change or switch off or untick this automatically determined by Workbench and redirect everything to your Z network drive. Otherwise, you get various problems with it. More generally, the geometry import. There are two options for geometry editing, and there's a design modeler, which has been around for quite a while, and then there's the space claim. So the default in some versions is space claim, so I wanted to make sure that I'm using the design modeler as the preferred geometry editor. Okay. Now, to start off, we want to do a static structural analysis. There's various analysis systems here on this window. So if we just double click on static structural, it'll set up a project here in this project schematic window. And the first thing we can do, we can change the name of the project, not the name of the file, but so if we just click on that, flat plate. And hit enter. So in this project there are a number of steps and you have to go through them in sequence. The engineering data is already ticked. You don't strictly need to go into that, but we will have a look at it. In the geometry, you define, as the name suggests, you define the geometry of what you want to model. Okay, then in the model you assign the material to the geometry, you apply loads, support conditions, etc. And then you run through the setup kind of follows directly from the model. The two main steps you go into are the geometry first, then the model. So we'll see that. But before we start on that, let's have a look at the engineering data. So we just double click on that and this window opens up. Now structural steel is by default the material is defined. And if we look down below here, you see all the properties. Young's modulus, Poisson's ratio. The units here are pascals. We can change the units there to newtons and millimeters, perhaps that might be more familiar. Now, to get it actually to display them, then display the values in project units. We also need to do that. So, Young's modulus 2 by 10 to the 5, that's 200,000 newtons per square millimeter or megapascals, so that's fine. So, it says up here we can click to add a new material. So if we want to do that, and we can open up our engineering. If you click on this this tab up here, engineering data sources, there are lots of materials predefined. So if we, for example, click on general materials there, we see down here concrete, so we could say add that by click on the plus. Structural steel, aluminium alloy, we click on that, add that. Okay, and we click on this engineering data sources tab again just to close it. Okay, and now back in our engineering data for the project, we have aluminium, Young's modulus 71,000, concrete, Young's modulus 30,000, and structural steel. We can change all these properties. We can define plastic behavior, nonlinear behavior. Ansys has a pretty sophisticated material model capability. So having done that, we can just close that and double click on geometry to start the design modeler. And down in the bottom left hand corner of the screen is a starting design modeler. It can take a few minutes to start up. Now this is the startup design modeler window. First thing to do in this is to set the units. It's set to meters. It's more convenient to work in millimeters, so for this project, so I'll click that. The screen changes. The scale down at the bottom here shows that. We will draw the rectangle in the XY plane, so we click on the XY plane, right click on it and say look at that. So we'll see the Y, X axis, X and Y and Z coming out of the page. Okay. Now we want to draw a rectangle which is 1,000 millimeters long by 140 millimeters high. Now to do that, we go into sketching, which is this tab over here on the left hand side. Now it can be convenient to switch on a grid and make sure that it snaps to the grid. You don't have to do it. I'll use both the grid and dimension lines and they're alternative ways perhaps of doing things. But I'm going to show the grid first of all. It switches on. The major grid spacing 10 millimeters. That seems reasonable enough, I think, at the moment. Yeah. So I'm going to have one minor step. So I'll change that to 1. Okay, so we show the grid. We click to snap to the grid when we're drawing. The major grid spacing is 10 millimeters. That's okay. I'll type in 1 minor step per major because it snaps to the minor grid. So the major grid is what it shows. The snapping is to the minor grid. So this setting is going to snap to the nearest 10 millimeters. Okay. So we can now go into draw. I'm going to draw a rectangle. Now if we look at the scale here, 30 millimeters. So I click in this region and do Control and mouse wheel. I can reduce it down to this. It's not strictly necessary to do this. As we'll see, we can use the dimension lines, but I want to draw something that's about 1 meter long. So okay, so that's 400 millimeters. So the screen should be about 1 meter long. So if I now go into draw a rectangle, so in the draw there's lines, rectangles, circles, etc. So we can pick a rectangle, and we now get this drawing, the pencil icon or pen icon, and in down in the bottom right hand corner it gives you the current coordinates of the pen. So as we move the pen, you can see there it's changing, -490. So I want to go 500. I'm going to use the origin of the axis as the center of the plate. Okay, so I want to come down to 70 millimeters. Start that again. So I want to come down to -500 and -70. There. And click and hold and then drag, and it starts drawing a rectangle. And I'll keep going until I get to plus 570, again in the bottom right hand corner, 570, and release that, and it has drawn a rectangle. To actually see it, you may need to switch off the grid. So that's in settings again, grid, and show it. You can snap to the grid even though if it's not visible, which is maybe the most convenient way to do things. Now, to double check on that, and maybe an alternative way is to, rather than snapping to the grid, you can draw a rectangle roughly and then set dimension lines on it. So that's over on the left hand side, there's dimensions, so click on that. So I'm going to put in a horizontal dimension, so click on that, and it highlights between that line and that line, and then I can just bring the mouse down to where I want the dimension line to actually appear. So maybe down somewhere here, and then click, and I check over here. It is 1000 millimeters, which is, as expected. But you can change that. So if I change it to 1200, it changes the. If I change it back to 1000, it's fine. Okay. So, and if I click on it, it should. Yes, it highlights the dimension line. Okay, so now I want a vertical dimension line between the bottom of the rectangle and the top. So click there, just move the mouse. You don't, not without dragging, just without clicking it, just move the mouse over there and then click and check that the 140 is correct, which it is. Alright, so that's that. I now want to draw a circle, and I'll just call up the diagram again to see what we're doing, to remind us what we're seeking to draw. So this is what we're trying to draw. This is the 1000 millimeters by 140. We've drawn that. We now want to draw this circle, which is centered 200 millimeters from the center of the bar and a radius of 52 and diameter 104. So the center of the circle should be in the center of the bar, basically. Okay, so let's go back to this and do that. So we go to draw, circle. Now roughly, again, it's going to be roughly here, draw a circle, and roughly like that, okay? And I go into dimensions again. First of all, dimension the radius, so click on radius, and then you highlight the circle, and then move the mouse and click it again, and the circle, I said, is 52, so that's reducing that slightly. Now I want to locate this. It doesn't really matter, but I do want to I want to locate the center of the circle 200 millimeters from the center of the bar. Okay, so so we put in a horizontal dimension line between this point, or between this line rather, and this point, and bring the mouse down to here and click, and that H4 dimension is 210. Okay, so I'll just change it to 200, and that moves the whole circle. The center of the circle is on the center line, so that's all fine. Now to draw the notches, these notches, we want to draw first of all circles with 11.5, and we want the center of the circle to be 5.5 above and below the edge of the bar. Okay, so first of all, let's draw well, we'll start with one. We'll draw a circle. The center is roughly somewhere here. No, it's probably too big, but that's very approximately where we want it. And we'll put in dimensions again, the radius. Click on that, click again, and the radius, that's called R5, so we'll look for R5 down here, and it needs to be 11.5, which is quite small. Okay, so we can zoom in on this. There are various icons up here at the top to rotate, to pan, to zoom, to box zoom, and to zoom to fit. Okay, box zoom is quite convenient if you click on that, and then just drag into it, and we focus in on what we're doing. Okay, we can go back out again to introduce the horizontal dimension line. So I want a horizontal dimension line between here and this center of the circle, and I want that to be and that's H6, and I want that to be 200. So change that, so that moves the circle. So that's fine. Now I want a vertical dimension line between the point, the center of the circle, and this line here. So that needs to be, that's V7, so that needs to be 5.5 millimeters. So that'll move this, yep, okay, so that'll move the circle down. Okay, while we're doing that, we may as well draw the other circle in here now. Draw circle, and this time it's down here somewhere. Okay, and dimensions, again, go through the same thing. The radius of that circle there is R8, and that's again 11.5. Dimension lines horizontal between the center of the circle and this line here. That's H9, and that has to be 200, and it is, so that's correct. That's been, the center snapped to the grid correctly. Now the vertical dimension, we need a vertical dimension to locate between this line here and the center of the circle here, and that V10 should be 5.5 again, and that's fine. Okay, now we can box zoom using this plus icon up here, and we'll just zoom into that section to see what we're doing. Now this is to be a circular notch, so I need to trim away the upper part of this circle here and the part of the bar. So that's in modify, in sketching, and trim. All right, and that then, so if it's an intelligent kind of trim, so if I click on that part of the circle, it trims the circle as required. Click on that part of that. Click on this circle here below the line, and click on this line here, and it trims. Now some of the dimension lines are hiding what we've done, but that has achieved what we want. Okay, so that is now ready. I think everything is okay. The dimensions are on the location of the circle. Yep. All right. So that now is just it's a sketch. Okay. And if we go back to the modeling and the XY plane, we have this sketch. All right. And it's purely that. It's not. There's no material associated. There's no thickness associated. It's just a rectangle. And to generate the thickness, which is 40 millimeters, we need to extrude this. Okay. Now that there is look at this. There is a button up here which says extrude. All right. So click on that, and click on that, and we have this dialog box down here. Okay, so the geometry is we highlight the sketch and apply that. So that's, we're going to extrude sketch 1. The direction is normal to the XY plane, so in the Z direction. I want it to be okay, it's stuck there. Let me pause this and fix that. Okay, I've resumed that. For some reason it sometimes freezes when I want to do this, but so I've just gone back to this window here and then double clicked on geometry again to just go back in. Seems to, and I now highlight that. What I want to do is type 40 there. Okay, and hit enter. Now, it hasn't done anything yet. We need to generate, and this we'll see there's lots of cases where we define something and then get it to generate. So click on generate up here, the lightning. It does that. Okay. Now, if we click on that blue, so we're looking at the Z-axis here. If we click on this blue sphere here, blue circle, it says ISO, so it gives you an ISO view. This rotate icon does as it says. You can rotate and look at everything there, and that looks okay. The sketch, you can hide the sketch and then click. So to get rid of the dimension lines, so and that, but that all looks fine. Okay, so go back to the ISO view, go back to that. Now, we're ready to go to the next stage, and that's covered in the next video, where we go into the model and define the material, define the loads and the support. Before we do that, always good to save the work. Okay, so save project, and it calls up a dialog box and it saves it. Saves quite a few files. It saves the main project file and then a folder associated with the file project. Okay, so it comes up with a save as, and in the folder that I designated my Z drive, Ansys projects, and we give the project a name. So I'll just, for example, place just call it version 1, and it saves it in a WB Workbench project file. But you see, it also creates a folder with lots of files associated with it. Okay, so we'll just save that. And we're now ready to go into the model, which is covered in the next video.